Okay, so okay, so ang di-discuss ko is earthquake engineering. So as you can see sa screen, ito yung ebook na ginawa ko. I just compiled everything na I think will be very important sa subject na to. So hindi naman talaga ako yung author, pero at least I was able to compile the needed references through this ebook. It's not really um, an official book. I just call this an ebook as a reference to this subject. Okay, you can see yung contents. Okay, first, mga earthquake related videos na dapat yung makita, should be discussed. Okay, you should realize yung importance ng earthquake, itong subject na to, because remember, we are civil engineers and we are in a seismic prone country, and so definitely you will be designing buildings or residential houses na subjected to earthquake. Okay, so, but before that, you need to familiarize yourself dito sa concept or even sa basics, mga terms and definitions. Okay, so once okay na tayo sa mga definitions and terms, that's the time next chapter will be the static force method. Okay, equivalent static force method. So static force method, from the word itself, static, no? And by now you should be now familiar with the static. That means it's not moving. Okay, diba? Kasi yung before engineering mechanics, yun yung first major subject nyo about structural analysis, wherein you analyze structure under static condition. Walang motion. Okay? But in reality, earthquake is moving. Your building is moving. That's why the term equivalent static. Although your building is moving during the earthquake, to simplify the analysis as engineers, to simplify everything, although it's moving, we perform an equivalent static force to the actually dynamic motion of the building. It turns out na in general, it's conservative. Lalo na sa mga low-rise building. Conservative pa nga yung equivalent static force. I could say this is a good enough approximation yung equivalent static force, lalo na kung regular shape, symmetrical yung building mo. Because again, in actual, it should be dynamic, not static. Okay? That's why on the later part, ito, chapter 4, my aim is to introduce the structural dynamics. Okay? Para maging familiar kayo sa equation of motion ng isang structure during the actual earthquake. Okay. Also, another issue is, why do we need to focus first on static force? Imagine, wala naman kasing supercomputer or matataas na RAM before. Even calculator, hindi pa masyadong gamit. So that as an engineers, they need to devise a way para ma-analyze ang building without using that much computer memory. Because sa dynamic, medyo kailangan mo na ng intensive equation, ng intensive matrix. Okay. Whereas sa static force method, pwede kang after you analyze, kuha mo yung base shear ng building due to earthquake, pwede ka na mag-portal method or cantilever method or factor method. Okay? So talagang gamit na gamit yung static force method if even now. No? So talagang yun yung the only way to analyze your building under earthquake. That's why we need to first uh, familiarize ourselves with the equivalent static force method. Okay, so ito yung mga laman. The importance of earthquake loading, seismic mass computation and design base shear, torsional distribution sa structure, frame analysis, factor method. Okay. And I guess, dito na pagdating sa factor method, familiar na kayo dyan. Kasi once you do the, by the way, hindi naman kakulong sa factor method yung gagawin mo. Pwede ka mag-portal or pwede ka mag-cantilever, whichever method na familiar ka. Then once you did the factor method, the lateral force analysis from the static force procedure, ma-generate mo na yung shear and moment diagram ng structure mo. Okay, so, and basically this whole procedure, static force method, will be the required output from you for the plates, because we have plates, corresponding plates na requirement sa subject na to. Okay. Now once we're done with the static force method, yun nga, we will proceed with the structural dynamics. Okay. And then we have the dynamic equilibrium equation discussion. Okay. So dynamics, the first approach will be the undamped free vibration. Then after the undamped, syempre may damp. Okay. Then discuss natin yung damping, logarithmic decrement. Then after that, this is the undamped force vibration. So dito na introduce yung meron kang vibration, tapos meron kang force. Okay, nag-vibrate yung building due to a certain force. Then, so of course, merong undamped, meron ding damp. Then we will try to solve the equation of motion of each of those cases. Okay. So, yung iba dito, i-skip natin yan because I'm also using this reference or ebook sa Masterat. That's why medyo mabigat yung ibang topics. Okay. Pero since this is for an undergraduate course, ipipick ko lang yung mga kailangan nyo. Okay. Then, magdi-discuss din ako ng numerical methods para ma-solve nyo yung equation of motion. Okay. Then, concept of the response spectrum, because yung response spectrum, yung curve na ganon, because that's what you need sa dynamic analysis. Okay. Now, once we're done with the single degrees of freedom, by the way, yung diniscuss ko kanina sa introduction ng dynamics, that's only talking about single degrees of freedom. From the word, single degrees of freedom. Pakita ko. Okay. So again, inuna natin statics. Then we go to dynamics. So earthquake engineering. Yeah. So sa dynamics, unahin muna natin yung SDOF before yung MDOF. SDOF, single degrees of freedom system, while MDOF is multi-degree of freedom system. So ito, hindi na tayo dadaan dito kasi pang masteral level na to. Ito, introduction lang. Kasi nga undergraduate lang naman. Okay. Yeah. So ganyan i-discuss natin. By the way, what is single degree of freedom system? From the word single, nag-iisa. No? Because we will assume our structure originally from this drawing, yan, from that one, we will just assume that is a single structure. No? Single structure. Yan. Parang cantilever column. Degree. You should be familiar with this now because sa structural analysis, you are talking about degrees of freedom. No? So, ilalump natin yung mass natin dito. This is the mass. Of course, lahat ng building may mass. Tapos, you assume this whole structure is a cantilever column na may mass. And this structure has also what? Bukod sa mass. K, stiffness. Basically, ganyan. Single degrees of freedom system. Kaya nga, during earthquake, nakikita nyo, gumagano. Single degrees. Sabihin, isang degrees of freedom because we assume na yung displacement mo is just dito, on the x direction. Okay. Just, yan. Yan. So, delta x. Yan na. So, syempre, ano yan? Pwede ka dito. Yan. Okay. So, may displacement ka din dyan. So, that's what SDOF means. How about MDOF? So, para na rin for your understanding. Siyempre, engineer tayo. We always wanted to idealize things, to simplify things para madaling i-analyze. That's what's been going on, no? Sa field natin. You need to simplify things, to idealize things para ma-analyze mo siya. Okay, because if we didn't do that, you will require a very high efficient, high supercomputer machine to analyze because nagdedepende ang analysis of a building sa inassume mong degrees of freedom. For example, this one, isa lang yung degrees of freedom mo. That means, isa lang yung unknown mo. Okay? Whereas, if you assume this as having many degrees of freedom, yung matrix mo, malaki. Malaki yung matrix mo niyan. Therefore, pag malaki yung matrix mo, malaki yung running time sa computer. Okay? Which leads me to this equation from the direct stiffness method. P equals KU. Remember, U is the displacement, K is the stiffness, and P is the force. Okay? Yan lang basically yung equation ng structural analysis pag nag-analyze, no? That means force. Imagine, this is in a matrix form. K, this is also in matrix form. Therefore, yung U mo, in matrix form din. So, pag inoperate mo itong dalawang to get the displacement, so, ano nga ba equation ito? Displacement is equal to K inverse P. Yan. So, pag inoperate mo yung equation na yan, it will be depending upon dun sa inassume mong size of matrix. Diba? And yung size of matrix mo will depends upon how many degrees of freedom ang inassume mo. And in reality, you can assume an infinite amount degrees of freedom sa structure mo. So, as an engineer, dun papasok yung engineering judgment. Yung assumption natin na we need to simplify things. Such like for example, truss, action member. You just assume na meron siyang either tension or compression. With that assumption, nagkaroon ka lang ng 2 degrees of freedom. Meron kang delta x, and then meron ka ding delta y. Okay? Because of that assumption, naging dalawa lang yung degrees of freedom mo dun sa joint na yun. That's why yung size ng matrix niyan, yung K niyan is 4 by 4 because dalawa dito, dalawa sa end na to, dalawa ulit dito, so that's 4. Okay? Isang member pa lang yun. So, ang unknown nito, ang size ng matrix nito, stiffness matrix is 4 by 4. Just for one member. Okay? So, balik ulit tayo sa earthquake engineering. Because, yun nga, no? You can tie up this concept because earthquake engineering is the discussion ng earthquake force na isasubject mo sa building mo. Okay? Then, hindi ko maiiwasang i-insert yung concept ng stiffness method or structural analysis. Kasi nga, structural engineers tayo. Itinatay in ko yun, yung dalawa. Okay? So, that's it. So, that's just for the introduction. Okay.